Okay, so now I'm going to give you a little bit of my knowledge that I learned and how I learned it about how the blood returns to the heart through the veins. Remember earlier I did say that veins ends in IN, and that's how I remember that it goes into the heart. And then, but we know I know the arteries are filled with blood that's pumped from the heart. So they have a moving force that are that's pushing that blood through the arteries. So the question at hand and what I was having to learn is, how does the blood get back to the heart through the veins? And how does it not, since it doesn't have a forceful push through it, how does it not just sit still in the veins and move backwards in it with gravity downpull and stuff like that? So that's the question at hand. This is how I learned it. It's not a complicated thing. I can't say a whole lot about it because it's self-explanatory. Like I said 100 times in these videos, seeing it animated makes it make sense, and there's not a whole lot you can say about it once you see it working. You know? So I'm going to let this video play and reflect on it a little bit more at the end.
Venous valves are hinge-like flaps formed from folds of the tunica intima. Venous valves are most abundant in the veins of the limbs, where the upward flow of blood is opposed by gravity. The one-way venous valves prevent backflow as blood travels toward the heart. Click on a valve to see the direction of blood flow.
All right, I'll click on the valve. It's like a lock, like the channel lock, like the Panama Canal. It moves into one section, and then it moves into the next, without being able to get back out. That's what I think it looks like. It goes up into here, bam. And this closes, the gate closes, kind of, so to speak, and you know, it can't go back this way. So to me, it reminds me of a lock. If that's any clever little way to tell how I learned it.
Contracting skeletal muscles press against veins, forcing blood toward the one-way valves.
So this is how the blood is moved towards the heart. See here, toward the heart. That's how I learned it. I see that it's going toward the heart with the arrow pointing up. But there's more to it than this. This is just a little bit. This is the actual muscular pump. Now, the objective that I'm covering right now talks about skeletal muscle in general. And another part of the skeletal muscle, and I didn't even think about this until I just happened to be watching these slides, is a system we call the respiratory pump. Now, I'm going to go to the next slide because it plays it's skeletal muscle, but it plays a totally different role.
Pressure changes occurring in the ventral body cavity during breathing create the respiratory pump that sucks blood upward toward the heart. As we inhale, pressure in the thoracic cavity decreases. Meanwhile, pressure increases in the abdominal cavity, squeezing abdominal veins. These unequal pressures create an upward sucking effect that pulls blood toward the heart.
See, this is not talking about the skeletal muscle that directly relates to the actual vein itself, but I mean, what we're talking about here, this is skeletal muscle. When we breathe in and out, we are utilizing skeletal muscle. So in that sense, skeletal muscle plays a role in pulling the blood to the up to the heart again in that sense.